My name is Steve. Welcome back to my shop. Well, today I've got what would seem to be on the surface a very simple job to do. And I'm going to bring it in a little closer because you probably can't even see it. I've got some number 8 brass washers and I need to open up the hole in them a little bit. So let me show you how I did it. I've got these number 8 brass washers and I need to fit them onto a 5mm threaded shaft. I could use a larger outside diameter washer, but I really don't want to. I want to keep the outside diameter as small as possible. They're actually being used as spacers. And there are several ways that this could be done. I have on my lathe, I have the Atlas 10-inch lathe, and I have a full set of 3 AT collets, and I could take and machine an emergency collet to fit it. But since most of my viewers are home shop machinists, they might not have a collet or an emergency collet available. I'm going to show you how to make a simple little collet out of a piece of aluminum to accomplish this job. So let's go over to the whiteboard and I'll show you what my plan is. Most of the dimensions on this collet that I'm going to make are not critical by any means. The only critical dimension is the diameter of the washer, which is 9.33 millimeters. So what I'm going to do is I'm going to take a piece of aluminum bar. It currently is about 19 millimeters in diameter, 3/4 inch. I'm going to turn it down, flange down on it to 15 millimeters approximately. I'm going to turn the body of it down to about 12 millimeters. I'm going to bore the whole thing or drill the whole thing with a 6mm hole for clearance, and then we'll take it over to the milling machine and slot it. So let's get started. Okay, the first thing I'm going to do is face it off. I'm going to center drill it. I'm going to pull it out and turn approximately 2 inches down to 12 millimeter. Decided that the 2 inches is going to be the overall length on this. I'm going to kind of designing as I go, so I'll turn it down to 15 millimeters for the 2-inch length, and then once I reach that I'll do the balance of it at 12 millimeters. 14.95. It's pretty close. That's good for me. Now I'm going to turn 1 3/4 inches of it down to 12 millimeter. $12 right on the button. Next thing I'm going to do is drill it all the way through with a 6mm drill. Okay, that'll do it. I'll put the parting tool in and cut it off. Okay, I've turned the piece around. I'm going to face it off. Okay, now I have to drill or machine the recess for the flat washer. Now the flat washer is 0.8 millimeters thick. And it's 9.33 millimeters in diameter. Now the closest thing that I have, because the hole needs to be a flat bottom, or the recess needs to be flat bottom, and I have a 5/16 end mill, which I'm going to start the recess with, because that'll give me a nice flat bottom to start with. If I go a little too deep, it's not a problem, because I've still got more meat on that flange that I can take and face the flange off till I get the depth exactly where I want it. I'm exactly 0.8 millimeter. I couldn't do that again if I tried. I'll show you my setup for boring it. Let me try and zoom you in a little bit. I was setting up for shooting this segment of the video and decided to take a couple of light cuts before I turned the camera on, and I'm already out to size. So I use a gauge pin. My gauge pins are fractional, and the 9.33 millimeter came out to about 3.368. I got a 367 gauge pin that just fits. If I take my flat washer, lay it in there, well, I can probably take one more very light cut. It's no, there it is. That's perfect. It fits right in there flush. I like that. I'm not even going to face it off. I like the depth on it. Very good. Now I'm going to take the collet that I just machined over to the milling machine and cut some slots in it. See you over at the milling machine. I've got to come in from the other side to do conventional milling, and with the vise set up the way it is right now, I don't have room to do that. So I'm going to cheat. I'm going to put a 1, 2, 3 block in the vise. That'll move the collet block over far enough to give me clearance on the saw. That'll do it. I've already set my height. So let's give it a try. That's as far as I can go. Alright. I'm turning the saw a little bit faster than I normally would, but on this aluminum it's doing just fine. Now let's okay, let's here's my final cut. Bozo just struck. I cut it in the wrong spot. Let's rotate it one more time. That's where it's supposed to be. Yeah, there it is. With one too many cuts in it. But it'll work. Here's my finished collet with one too many slits in it. But if I had to be a lot more accurate on this, I would remake the whole thing, but I don't think it'll really make any difference. I just have to hold a washer to drill a hole in it. The washer fits in there nicely. Now I'm going to take it over to the lathe and drill a hole. And now I have put the collet in the 3-jaw chuck and lined up the jaws with the spaces in between. Of course, we know we have an extra cut on it. And now I will tighten it up. We put my 5mm drill in and let's drill it. Here's my 5mm threaded piece. Fits in there perfect. Success! Now all I have left to do is deburr it. Put a little bevel in there, and it is finished. Well, there they are. All 4 of them. Oops. Well, I see it. I turn them over in the collet and deburred the back side also because it had a little burr sticking out. I deburred it. Here's number 4. So there it is, with one too many slots in it. Didn't really affect it. If I had to do something that had required extreme accuracy, I would have had to remake this collet. But the extra slot really didn't make any difference for what we're doing. These are strictly spacers, and they need to fit over this 5mm shaft, which works perfect. So thanks for watching, and I'll see you in the next video.